Welcome to this last minute revision for Physics Science Paper 1 for those that are writing their GCE and external exams. So what does this last minute revision include? So in this last minute revision, we are going to talk about the top 10 topics which I posted in the 2026 prediction for science paper 1. So all those questions, we are going to look at the most repeated questions on those 10 topics. So don't forget to subscribe to my channel, share and comment if the video was helpful to you. And for those that want to access the entire last minute revision package, don't forget to inbox the number on the screen, which is 0967941401. So this is the number which you should inbox in case you want the full last minute revision. So what will this full last minute revision contains? So it will contain current electricity, general physics, mechanics, atomic physics, all those important topics which will help you get a lot of marks in physics. So without wasting much of your time, let's begin. So our first episode, we are going to look at current electricity. We are going to solve some questions which came in 2025 up to 2021, just current electricity, so that you know and understand how questions come on current electricity. So to begin, the first question is saying a battery moves a charge of 70 coulombs around the circuit at a constant rate in 1 minute. So we are saying that this battery moves a charge of 70 coulombs in 1 minute. What is the current flowing in the circuit? So this question is asking us to calculate the current. So remember the formula for current. So the formula for current goes like this. So it is current is equals to charge divided by by time. So this is the formula which we use whenever we are calculating current, when we have time and charge. So remember, current has a lot of formula. So remember, you have to know which formula to use depending on what you have been given. So for example, you can't use that formula for resistance and voltage because we don't have resistance and voltage here. So you have to keep that in mind. So after identifying the formula which you are going to use, next is for you to collect the data. So here, what is our data? So our first thing is our current, our second thing is our charge, then third we have time. So what is our current? So our current is the one which we are calculating. So we put a question mark. Moving on to our charge. What is our charge? So our charge is 70 coulombs. What is our time? So our time is 1 minute. So our step 2 is done. We have written the data. The next step, which is the important step, check the units. So the next step is one of the most important steps. Check the units. What are the units for time? So remember, I told you time here should be always in seconds. Then here is in coulomb. So since our time is in minute, we are going to convert this time into into seconds, because if we use this one, we are going to get our answer wrong. So we are going to say 1 minutes is equals to what? 60 seconds. Yeah. So meaning our time, we won't use 1 minute, but we are going to use what? 60 seconds. So here you can put 60 seconds. So now we have all the values which we need to do what? To calculate our current. So once you do like this, meaning your question is already done. What is remaining now is just what? To replace the symbols with numbers. So what is our charge? We have 70. What is our time? We have 60. Then if you divide, you find that your answer is 1.1666 amps. But if you round it off to 3 significant figures, you find your answer to be 1.17 amps, which is our D. So this is how multiple choice questions in physics are tricky. So you need to pay particular attention to units, because mostly in physics section A, the multiple choice part, they like examining you on units and also what? How you understand the conversion of units from minutes to seconds, seconds to hours, all those conversion units. So moving on to our second question, which is saying two resistors of 12 ohm and 24 ohms are arranged in parallel. A 4 amp current flows through a what? A 12 ohm resistor. So here we are saying that these two resistors, this one and this one, are connected in what? In parallel. How do we know that these two are connected in parallel? You look for what? For the junction. What did I say the junction looks like? So you look for a part which looks like this. So if you come here, you can see that we have this part here and we also have it here. So meaning these two are connected in what? In parallel. So, how do you calculate the current in parallel? Remember, the question is saying, what is the reading on the ammeter? So, how do we know that they are looking for current? Because we know that ammeter measures what? Current. So, in the moment you hear the word ammeter, whatever should come into your mind is what? Current. They are asking for current. So now, how do you calculate current? So remember the principles I told you. I told you that when we have a parallel circuit, remember, whenever we have a parallel circuit, the current is what? Is different. So remember, so again, I'm writing it here. In parallel, the current is different, while the voltage is same. So these are the 2 points which you need to understand whenever you are talking about parallel circuit. So you need to understand that in parallel, the current is different while the voltage is the same. So now, having this concept in mind, let's look at how we can approach this question. So first step is you have to write what? The formula. So what is the formula for current? So the formula for current here, since we have resistance, we don't have time. So the formula we are going to use is current is equals to voltage times voltage divided by what? Resistance. So we are going to use what is known as the Ohm's law. So Ohm's law states that the current is directly proportional to the potential difference across 2 points and inversely proportional to the resistance of the conducting material. So that is the principle, or that is what Ohm's law states. Basically, it states the formula for current when you have voltage and resistance. So now that we have known what the formula to use is, we are going to identify our data. So I said what the current is different, but the voltage is the same. So our first step is to write the formula. So we have our formula here. So now we don't know the current which is passing through where this resistor. So it will be a bit of challenge for us to calculate what the total current, because when they tell you to write the reading on the ammeter shows the total current passing through the circuit. So here it is where it splits. Yeah. So which means we have to find our current which is present in what? In this part. So now how can we calculate the current which is present here? So remember I told you the voltage is the same. So we are going to use that principle of voltage being the same. Why? We are going to solve first the voltage of these two, this resistor and this current, because if we have a resistor and a current, we can solve what? Voltage. So we are going to say current is equals to voltage over resistance. What is our current? Our current is 4. What is our voltage? Is the one which we are calculating. What is our resistance? Which is 12. So if you multiply 12 times 4, you will find your answer to be 48 volts. So meaning the total voltage which is passing through this entire circuit is what? 48 volts. But mind you, there is no 48 on the answer. And we are not calculating the voltage. We are calculating the current. Yeah. So this is how multiple choice questions come. They look simple, but they are a bit of challenging, where you need to apply the concept I'm giving you here. So now we have calculated the voltage and we say the voltage is the same. So now we can calculate what? Our second current. So you say now, what is our second current is equals to voltage over resistor. So we have our voltage which is 48. Then we have our second resistor which is 24. So if you divide 48 plus 24, you find that your second current is what? 2 amps. Yeah. So we have calculated our second current. So now we have two currents. So meaning the ammeter cannot give us two current. Remember we have this 4 current here and this 2 amps which we have calculated here. So now what the ammeter gives us is the total current. Remember the what? The total current. So meaning you have to add the what? So you here you say the total current is equals to 4 amps plus 2 amps, which gives us 6 amps as our total currents, which gives our answer to be B. So this is how you can reason in your what? MCQs, or your multiple choice question. So moving on to our third and final multiple choice question which we'll look at. So these are the examples, or this is the format on which the question will come. You either find the question on current using this formula, or you find the question on current using the formula for time, or you find a question on cost like we are going to look at. So the question on cost is saying an emission water is marked 240 volts, 2 kilowatts, and it is run for 120 minutes if the cost of 1 unit of electricity is 0.8 ngwe. What is the cost of running this water heater? So this question is saying they have a water heater, and this water heater has been marked with what? 240 volts, 2 kilowatts. So what is the meaning of these two units? So remember, whenever you see volts, it's the what? Potential difference. Whenever you see watts or kilowatts, this is the power. So here we have the power and the potential difference. So the question is asking us to calculate the cost. So how do you calculate the cost? So for you to know how to calculate the cost, first you need to know the formula for energy. How do we calculate energy? So the simplest way, or the formula which we use to calculate energy is, so you need to remember this formula. Energy is equals to power times time. So here is where you have to be careful again whenever you are looking at the formula for energy. So remember, I told you. So I'll even put here we have P, then here we have capital T. So the reason I'm putting capital T here is to show you the difference between this T and this T in our first question. So the first time should always be in second. That's why I've used the small letter. The second time, however, should be in hours. That's why I've put a capital T. So remember, the first T should be in what? In seconds, which is the smallest. Second T should be in hours. Yeah, it should be in hours. Then the power. So power should be in kilowatts. Yeah, so power should not be in watts again. It should be in kilowatts. So you have to remember these things I'm telling you. Why are we saying power and time should be in kilowatts and hour? So remember, the units for electricity are in kilowatts per hour. So that is why the power needs to be in kilowatts and the time should be in hours. So this question was simple because the power was already